Hi, Algebra 1. Welcome to your last lesson for this week. Hopefully you've been keeping up with the videos and the practice problems and Khan Academy. Hopefully by now your quiz is finished and has been emailed to me. We're going to end the week on a very short lesson. We will be starting Chapter 7, Section 5, but we'll only be doing one set of problems and practice problems. We will just be covering one particular property of exponents, as you can see on my board. Okay, so here we are. We're diving right in. In your book, page 440, you should have paper and pencil to take notes, or the note handout that I have already provided you with. So if we've been dealing with multiplying bases, we've been dealing with having quantities raised to a power, and today we are going to move to division. What happens when we are dividing bases, similar bases with powers? So you look at my first example. If I have the problem 4 to the 5th divided by 4 to the 3rd. Remember, a fraction bar is a division symbol. What would we do? Well, let's think through this first and see if we can find the property hidden in there. 4 to the 5th means I'm going to take 4 and multiply it by itself 5 times. In the bottom of my fraction, I have 4 multiplying by itself 3 times. 4 times 4 times 4. Well, we know whenever we have things written as factors that we can cancel similar things top and bottom. So if I were to go through and do some canceling, top, bottom, top, bottom, top, bottom, what does that leave me with in my problem? I still have 4, and I have 2 of them being multiplied together, so I have 4 squared. If I were simplifying this, I'd call it 16. But for the sake of establishing our property, I'm going to leave it as 4 squared. So you can kind of see what happened here is I took my exponent in my numerator and I subtracted the exponent in the denominator, because 5 minus 3 gives me 2. That leads us to our property. Anytime we have similar bases and they are being divided, we are subtracting the exponents. When we were multiplying, we added the exponents. Now we're dividing, so we're going to do the opposite operation and subtract. An important thing I want to point out is that these properties, all of the ones that we've been talking about, only work when our base is not 0. Because as we discussed on the first day, 0 to any power is 0. So these only work for non-zero numbers. It has been written in your book and in your note handouts, but it's one thing that I wanted to point out. These only work if it's not 0. Okay, so two examples that we see are 2 to the 6th divided by 2 squared. If I'm dividing with exponents, I'm going to subtract. So I would get 2 to the 6th minus 2, which is 4. Our next one, dealing with x to the same base. My base doesn't change. 4 minus 7 would be my exponent. Well, what is 4 minus 7? It is -3. So my answer for this would be x to the -3rd power. But remember, I can't leave it like that. It's not finished until I've dealt with that negative exponent by moving it to the denominator. Okay, let's dive in and do problem number 1 from your book or your handout. And I have that written here on my next whiteboard. There's actually 2 problems that go with that, A and B. A is very simple, just like what we just did. And then B just makes it a little bit harder. So in letter A, I have x to the 8th divided by x cubed, same base, my x. So I know I'm going to subtract my exponents. So my answer for this is x to the 5th. Simple enough. Well, look at letter B. What happens here? Now I have 2 different variables going on, 2 different bases. Well, these rules only apply if you have the same base. So I'm going to have to apply my properties with my m's and then apply my properties with my n's. So I see right here, I have m squared divided by m to the 5th. So I would have m, my base doesn't change, 2 minus 5 is negative 3. Let's deal with my n's next. N, my base doesn't change, 4 minus 3 is 1. Well, you'll notice, again, I'm not done yet because I have a negative exponent there. I need to apply my property from last week that anything with a negative exponent actually moves to the denominator and becomes positive. So I take that m cubed and I move it down. And I'm just going to erase it, leaving me, and that 1 doesn't need to be written. My final answer for letter B is n over m cubed. This is where you need to pause the video and try the 4 practice problems in your notes or the got it problems under problem 1, and then restart the video to go over them. I'm going to take this time to write those problems down. These darker colors don't like to come off as easily. Okay, we have 4 to go over. They get a little bit harder as we move through, actually. So number 1 starts out really nice and easy here. I've got y to the 5th divided by y to the 4th. I notice I only have y's in this problem, so my properties are going to apply here. And I'm dividing, so that means I subtract my exponents. 5 minus 4 is 1. So notice that my answer is just y, because I don't need to include that exponent of 1. It is assumed. Look at my next one though. I have d cubed divided by d to the 9th. I know my base is d. It's not going to change, but my exponent is. And I know I'm going to subtract. Make sure you don't switch the order here. My numerator, or my top exponent, minus my denominator exponent. Even if the top is larger, it's still math I can do. I'm going to get a negative number. So 3 minus 9 is negative 6. So my answer is d to the negative 6th power. But I cannot leave it like that. I know I need to still apply my property from last week. Take that negative exponent, move it to the denominator, and make it positive. Okay. Number 3, going back to that second example we did, now we have we have 2 different bases in number 3. Looking at number 4, it's going to get a little bit crazy. But in this one, I know I'm going to deal with my k's separately, and then I'm going to deal with my j's. So I'm going to, because I'm dividing, I'm going to subtract. My k will have an exponent of 6 minus, what exponent is that? 0? No, remember, if it's not an exponent, it's the assumed 1. 6 minus 1 gives me k to the 5th. I have to squeeze this one in. J's, I have 2 in the top, 5 in the bottom. 2 minus 5 gives me negative 3. Remember, I cannot leave it like that. So my final answer actually moves this j to the denominator, making it a positive 3. So my answer for number 3 is k to the 5th over j cubed. Number 4, I don't think I left enough room there, so what I'm going to do is actually do the work over here. Number 3, we're going to erase that. So for number 4, I need to notice right away that I have x, I have x's, I have y's, and I have z's. We're going to talk about our x first because something specific happens there. Let's deal with that. They have the same base, so my properties apply. I'm dividing x to the 4th divided by x to the 4th. Well, that means I would have x to the 4 minus 4, because when I divide with exponents, I subtract the powers. So that gives me x to the 0. What is x to the 0? We know from last week that anything to the 0 power, besides 0, is 1. So I have 1 as my answer there. Well, I'm going to have 1, and I'm going to keep going with my y's and my z's. But this is all multiplication. So I actually don't even need to include that because obviously it's being multiplied by 1. So I can drop that. I could have seen that too back here at this problem because we know that anything divided by itself is 1. Or it takes me back to what we did on the very first screen. Same things in the top, same things in the bottom. They cancel each other out right away. So you can catch problems like this 2 ways. Thinking through your exponent rules. 4 minus 4 is 0. Anything with a 0 power is 1. Or just recognizing same, top and bottom, they cancel each other out. That means we can move on to our y's though. We have this. We have y to the negative 1 divided by y to the negative 5th. So that means my math problem is y to the negative 1 minus negative 5. Don't lose your negatives here. But I know that anytime I subtract a negative, what's really happening? They cancel out to be a positive. So negative 1 plus 5 gives me y to the 4th. We're exploring a lot of possibilities in this problem. I'm done with my y's. Let's talk about our z's. I have z to the 8th divided by z to the 1st power. That means my z is going to be there. My base never changes. 8 minus 1 is 7. So my final answer here is y to the 4th, z to the 7th. Okay, that's it for today's lesson, just starting into 7.5. What you need to do is look at your note handout or RenWeb, and the suggested problems in your book are on page 443, numbers 9 through 23 odd. And then you need to go to Khan Academy and see the assignment there called Multiply and Divide Powers. Kind of brings in things we've been learning over the last couple days, and then this new concept. And again, they're very basic problems, but as we move into next week and finish section 7.5, you'll see that they get a little bit harder. So that wraps up this week, our first complete week of distance learning. If you are doing this before Friday, remember that we have a Zoom class scheduled for Friday at 10:42. And at this point, you should have turned in your quiz from Thursday. And if you finish all of your work, it's due today by Friday by 5 p.m. And then you are done. You are completely free and clear for the weekend. All right, please remember to be emailing me any questions that you have, and I hope you're hanging in there with all of this new crazy system that we have, and I hope you have a wonderful weekend. Bye, guys.